So in the last 2 weeks, I was at Next.js Night London and I was at Next.js Night in Amsterdam. And at both of those events, I got to see members of the Vercel and Next.js team show off Next 16.3. And admittedly, I hadn't looked at Next in quite a while. I think my last real busy experience with Next was back in the day when everything was cached and there was sort of nothing you could do about it. But seeing how it's changed, and I saw the launch of cache components, I think, at last year's Next.js conference as well, and seeing where the 16.3 preview is going, it's really cool to see the emphasis on declarative cache controls over everything, which is excellent. So you can be really specific about where you want that caching to be. And also just to see how much dedication the team has to making sure that your application is fast. And that's what the topic of my talk ended up being about. I've been thinking a lot recently with my job at PlanetScale about reducing people's egress. That is the amount of data that is being fetched from your database. And I'll go through that in my talk, which I'm going to present here in this video. But the reason I've titled this video what I have is Next.js is back, if you care, is that you need to have a degree of care to make sure that your application is really, really great. Because the team building Next.js, it's very clear they desperately care about making sure your application loads really quickly and it's as smooth and as good an experience as possible. But while you've never been able to build apps faster than ever, and you can build Next.js apps so quickly, you can build any kind of app so quickly now, it's still not going to be excellent if you don't really care. The agent's not going to care for you. So it's about you knowing exactly what you want from your application and what is making it slow. And if you don't know what's making it slow, I think that's probably what I'm most excited about with some of those updates. And I want to show this off first. This is the application that I chose to build for my talk at both of those nights. And it's a Next.js application. It's kind of like a block editor, like a rich text editing sort of experience like you'd have. It's backed by a Postgres database. I've got a list of pages on the left-hand side that I'm working on, and I've got a title here and some blocks to be writing there. But this insights thing, this was instant insights. This is really cool to see, is that if your app isn't as fast and as smooth as it could be, Next.js will now tell you in development mode. And that's really cool. And there's all these different ways to copy prompts here to say, hey, would you rather stream this in and have a skeleton? Or would you rather cache this if you know the parameters ahead of time? Or are you just okay with this holding up rendering on the page? And perhaps you can set a way to say, hey, ignore that. And again, in a really declarative way, this is what I want my code to do. And being declarative, a word I'm going to use a lot in this talk, as well as the word cache, definitely I'm going to wear that out. It's good for a number of reasons. It's good for you, especially, to know sort of what you want the code to do, but it's good for agents as well. The more hints that you can leave through your code base of how you want things done, the better agents will work with that code, and they'll continue to implement those patterns if they see why those things are implemented. They'll only fetch the data that they need when they know what data the application uses. So being very clear about your requirements has always been useful for humans. It's especially useful for agents as well. So without any further ado, what I'll do is I'll go back to cursor here and I'll put this code back in. I had really optimized this app, so I had thought before I built it. And then I went to the first Next.js Night Amsterdam and saw them show off these instant insights, upgraded to the preview, and it spotted that this was an optimization that I could have made. And so now the app loads really, really, really fast, which is excellent, faster than it did before. So let's go and have a look at the talk. So the talk that I gave was titled Faster and Cheaper. And that's kind of the typical PlanetScale experience when you come and grab a PlanetScale database, but this is the experience that all of your applications should have. So at best, when you're working with AI development, the code works, right? That's kind of the baseline, and that's what you really want. And I know that a lot of people have made an argument that taste is going to be the differentiator. And I'm not sure that I agree with that personally, because you know and I know that there's a lot of applications and services that they dominate their sector, they dominate their industry, and yet they're quite terrible applications. We all have worked with those applications we didn't want to before, but that's just what the sector uses. So it's great that the code works, but ideally, and I hope this is why you would go to a thing like Next.js Night, and this is why the people who build Next.js are building it the way they are, and that's why you're watching this video, is because you want to make better things. Ideally, your application's fast and it works really well and it's very smooth. That's the better state, but it only gets there if you care. And at worst, and that's what I really want to highlight in this video today, is at worst, if your application's bad, it's not just slow, but it can cost you money. If your application is fetching too much and too often, you're going to run up your egress rates. And So like your CPU is going to work too hard, you're going to fetch too much data too often, and that can add up when you hit scale. You don't want to, the thing used to be about, oh, if I hit Hacker News, I don't want my website to go down. I think that's less of a likelihood now, but if for whatever reason, your app hits wild popularity and all of those unoptimized fetches you were doing, now they quickly add up. You blast through your egress quota. It can cost you money. So it's important to look at slop for both making your application faster, but also making sure it doesn't cost you money. And prematurely optimizing is not a bad thing in this instance. You don't want to wait until you get that scary bill. Oh no, you hit scale. Now it's cost you a lot of money. You don't have to wait for that moment as a forcing function to fix these things. You fix them in advance, you'll get a better application sooner. So I wanted to illustrate a few patterns that are really worth keeping an eye on when it comes to developing. So and I know we don't write the code anymore, right? But there are still patterns in code that, as of this moment, agents will typically get wrong or bad. And this is what I really want to highlight here at the moment, is that I'm not saying here's a code snippet you should copy, but rather here's the sorts of things that agents will do unsupervised. And you could take like this video or my blog post that I wrote about this on the Planet Scale blog and give it to your agent and say, hey, just check out these patterns. And it'll, do the job of double checking. But I think it's worth building your personal context to know what to look for, to make sure the apps that you're building are really, really good. And so here on the left-hand side, like just having a query function from, here's like I'm using Drizzle ORM, just having a query that's going to select every column from a particular row, that's going to fetch way too much. Or worse, again, because it's imperative, you're not saying exactly what you need, it's unclear to the agent and to humans what you're actually using in the application from that row in the database. So returning only what you use there on the right-hand side, that's really important for both things, to limit the amount of content that you're pulling and also to make it very clear what you need. Because in this instance, get posts, that function is probably pulling this post list on the left-hand side. And I don't need to pull in, all of the content. If I was grabbing everything, I'd be grabbing this whole content column, which is a huge JSON-B column. So you can imagine how much slower it would make this query to fetch all of those every time I load the list of posts. I don't need to do that. I only want what I need. So you also want to make sure that you're returning less data. So this is an instance where writing data which is ingress, can actually become egress. And that is to make sure that if your function has this method on the end, this returning one, which I was only writing another demo application today and it did this exact thing. I was writing something to the database and it just returned everything. And this will actually return more than you actually wrote. So if I was to just like update the post and update the title, but say, hey, return everything from that row, again, it could be returning the entire JSON body of that big content area, which again is not what I want. So only return what you need if you need to return anything at all. Agents will typically write too much code, and so they'll return, the whole row even if you weren't using it in the application. So you want to fetch less often, and that's where we start to use these caching functions. You might have, different frameworks, different places to cache. Next.js's caching controls are really, really great, and here you can see this declarative nature of them. So first of all, when you write use cache there, that's part of that cache components, that is a signal to Next.js. I want you to cache this function, invocation, and the parameters that it has, and then you give it a name. So you write this cache tag here. You say, I'm using this human-readable identifier to say that if I ever want to invalidate this cache and force a revalidation of it, then I just need to invalidate this particular tag. And so that's what the relationship of these two things. That one, top one, used for cache, that's for Next.js. Cache tag, that's for you. And so to have that same get post function from before, but then have a cached version of it, that means that I can still fetch on demand when I want to have fresh data, but I can fetch a cached version of it, which is going to be much faster as well. And this can be dynamic too. So, if I'm going to get the post by the slug, then I can use a cache tag there that is dynamic in that it's using just this unique value, which means I can still invalidate just that page and just that fetch in the cache. So we want to invalidate and refresh on demand as well. So there's instances where you might want to revalidate where it's okay to leave stale data on the page for a short amount of time. There's going to be instances where that is definitely not okay. So for example, deleting a post from the database, I want to update this tag to say, hey, I've deleted this post. Let's get rid of that immediately out of the cache as well as out of the database. So you get controls on when to set up that cache, but also when to tear it down. It's important too to limit the blast radius of updates. So for example, not all updates are created equal. If we go back to my document here, making a change to this content area, that is going to send quite a large transfer over the wire. So I don't want to have to, update the entire page here and all these layouts because I'm only updating that content area there. Where, for example, if I'm going to edit just this title section, I've got a different function there because that is going to need to invalidate this list, and so that list is going to be need to be refreshed. So that means that when I'm making changes within this content area here, I'm not forcing a revalidation or re-rendering of the post list on the left-hand side. But when I do need to force that rendering, I can change this title here, and so that's using a different function. So splitting up those functions to perform those edits can be really important, just to make sure that those changes and the impact of them ripple through as little of the application as possible. So it's important too to fetch in priority order. So not all content on the page needs to be seen at the same time. So here on the left-hand side, if I'm loading the URL to load this particular page, this content area is the primary thing that I want to see first. And the list on the left-hand side, I can suspend that and stream that in later. I don't mind. I could put a loading spinner there, but personally, I hate loading spinners, and fetches from PlanetScar should be so quick that you don't really need to see them anyway. But I've set this up that I have actually suspended this list of posts here, but this content area on the right-hand side is actually server-side rendered. And so what I've done here, because this editor here, this editing block editor component that I've got, it's called Portable Text, and it has a rendering component as well as an editing component. Now, the editing component is super heavy and very interactive, so it has to be a client component, but I've got a server-rendered version of it, and you might see a flash for a second there where it's like half opacity, and then it sort of fades in. And I did that deliberately because I wanted the page to load incredibly quickly. We're doing the smallest possible piece amount of work on the server side to render that as quickly as possible, but as soon as it can become interactive, it is. So we're sort of fetching and rendering in priority order. I think I've stolen the next slide. Rendering in priority order. So that's what I was sort of saying there, is to have that sort of static content rendering, and then as soon as the editor is ready, that gets rendered in there, where is live. And also I've got some import things there to say that, hey, the editor should not be part of that server-side rendered bundle. So I'm keeping that as small as possible on the server and then only bringing it into the client side when I need it. It's also important to cache as few keys as possible, particularly when it comes to user input. So we have those dynamic tags for caching, and that's excellent. But when it comes to user input that's going to result in a cache, we want to reduce the number of potential caches that we can create. So, for example, here, if I was going to change the weather selector here, if I'm searching for London or, London in all caps with spaces either side of it, those shouldn't end up in different cache entries. We can normalize that, make it all lowercase, trim off any white space, and that's going to be useful. So that's just one very specific example, but in any way where you can reduce the number of tags that are going to return the same data, that's incredibly important, and especially, again, when it comes to user input. And fetching more or less often, you do get controls in Next.js as well over the lifetime of the cache too. So things like weather updates, I'd only want to cache it for a few minutes at the most because that can change quite variably. But there are other things that could, last for hours, and they're likely going to be okay. So you're in control of the length of time, and you can also even change the settings in the next config to sort of create your own named values for when things are cached and when they are revalidated, which is really cool again. And again, it's just all these controls that you get to put in your code so agents can read them. It's really, really neat. And then caching, but streaming children. This was a sort of important thing when building this demo as well, is that this component here, because this has to do an asynchronous lookup to fetch the weather, I didn't want loading those components to hold up, that server-side rendered data fetch. So the server-rendered version, it uses a cached version of this data if it has access to it. But on the first load, it isn't going to wait for those asynchronous fetches to complete in order to render this component. And so you can see there's a small, on the first load there, it said loading weather, ... And then on the second load, it was already there. So that meant that was going to come from the server as fast as possible, because these children components weren't going to wait on their own, asynchronous fetches, but we could just load the shell and then stream those in when they're ready. And then as soon as they're ready, they're cached for the next person and for the next visit to see, which is really, really cool. And then if you wanted to go further with this, there's also this idea of cache navigations and also remote caching as well. So if the in-memory cache isn't sort of long-lived enough for you, you can reach out to an external service and start saving those cache entries in there as well, so you get an even longer-lived cache. But yeah, that was the talk that I gave at both of those meetups, and it was just very cool to see where Next.js is now. But like I said at the beginning, above all else, seeing just how much that team care about making really performant apps, and it's really quite inspiring inspiring to see and inspiring to show that, we can all build things very quickly, but if you care, you're going to build something really great. And you can do that with Next.js, which is cool. So I hope you enjoyed this. If you have any questions, let me know. I'll put a link to the demo app in the description as well, and you can grab that on GitHub, and I'll see you in the next one.